Okay, here's Chemistry 1306. We're gonna go over a potassium formate solution. This is serious pH business here, located in chapter 16. First we begin with our problem. What is the pH of a solution containing 0.49 molar of HCOOH and 0.41 molar of HCOOK? The Ka, which is the rate constant for acid, is HCOOH is 1.7 times 10 to the negative 4. Now notice from our potassium formate that it is a strong electrolyte, so it disassociates completely in a solution. So as this disassociates completely, then we are left to work with what I have here. I've already written it down. When you start these problems, you need to write down your equation first and foremost. So we're basically going to go through our reactant, and then from our product we're going to create a rate constant. So from here, let me go ahead and fill in the blanks. We have our initial concentration for our reactant side. Now we don't have any hydrogen right now, but from the problem we have 0.41 for HCOO. So the change in everything for the ICE table, by the way, this is an ICE table. The I, the C, and the E are denoted for the initial, the change, and the equilibrium. We do these so we can find out our Kas. So our change, we use an X just as a variable. And this says that things are being used up, so we put a minus here. And over here, we just go ahead and put a plus X plus variable, because we are making things. This is the product side. So equilibrium is basically where we actually put the equations together. So from here, let's put this together. It'll be 0.49 minus X. And then over, oops, sorry about that. And then over here, we have our 0 and our plus X. So we'll go ahead and place just an X here. And then over here, we'll do 0.41 plus X. Now that we have our equilibrium, we will put this in our Ka equation. So the ionization constant, the Ka is equal to our hydronium. And then right here we have, this is denoted as our base. This is denoted down here as the acid, COOH. Great. So in terms, this up here would be our HCOO minus. And then down here, if you were to have written it like this, it would have been our that's how you would write it if you were just going through the motions. Let me go ahead and write it right here for you. So basically we would plug all of our information into here, and that's what I was doing over here. Ka is equal to our hydrogen multiplied by our concentration all over our acid. There we go. Better. Okay, now let's go ahead and plug things in. So we'll put our Ka in its spot, and don't forget it was right here in our given for our problem. that we're solving. So it's 1.7 times 10 to the negative 4. And we have our x, because hydrogen is still denoted by an x. And then we have our 0.41 plus x. And it's all on top of 0.49 minus x. Now, to go through this, you would probably have to do the quadratic equation, but since the amount that we would get would be so minute that it would be negligible, we're going to go ahead and just pretend, or we're gonna notice him, but we're just gonna go ahead and let him hide away. So we'll go ahead and take him out, and then up here we'll go ahead and pretend he doesn't. He's like at base camp. We care about him, but we don't really care about him right now. So we'll take him out, and that way we can just solve the equation more easily. So that leaves us with 0.1 over 0.49. A nice beautiful equation that we just have to solve for x. And using our algebraic skills, we can move things around. You just do the opposite of what's happening to it at that moment, using the order of operations. And so that will make our x equal to our hydrogen concentration of, and I'm going to write it right down here. I'll write it in a different color so you can see. 0.00020. And now that's just the the concentration. So we need to actually put it into our equation to get the real pH. So remember our pH equation. We are going to fit this on this paper. No worries, we have one right here. We're going to fit this on the equation. And let me go ahead and just zoom in a little bit. There we go. So now that we have the hydrogen concentration, we will create pH is equal to the negative log of our concentration. We'll just write it out just so we have a fresh memory of the formula, and we can go ahead and plug in. So negative log of 0.00020 is equal to, go ahead and plug it into the calculator, and we are left with 3.69. And that is our final step for this potassium formate solution problem.